So, say welcome to James Clean on the stage.
So, what was that? It's my great pleasure to be here, but with a little bit of trepidation. First of all, it's the talk that we had this morning. I mean, you know, how do you do a follow-up to that? And second of all, proud. So I may, you know, wander among you to keep you awake if that proves necessary. I have about 3 hours of material to cover in 45 minutes here, so we'll see how that goes too. This should be fun. This is a talk for nerds. We're going to look at code. How many people here do not write code? So if you don't worry, because I'm going to be talking about the concepts and then looking at the code as a way of illustrating the concepts. Okay? And I mean, it's not a real language, it's Ruby. So, fight. No, I've been learning Ruby here the past 6 months or so. And I mean, it's wonderful. The reason I'm using it for this talk is because it's a language that when you read a program in it, you believe you can understand it. And this is all about code comprehension. And I'm very deeply indebted to Steen, who's sitting up here in the front row. Most of this code is his. Or if I've changed it, you can disown it at any time and say, no, he screwed up here. But Steen was one of the pioneers in taking DCI into Ruby. This first started really exploding. Hello, wake up. There we go. Yeah, now I get 3. At the JAU conference 2 years ago, two JAUs ago, and everyone started doing DCI in their favorite programming language. So we have implementation probably have it in your favorite programming language. Somebody has probably done it. There's only one language in which it's a little weird in that there really isn't an implementation in Java in the same way that there really isn't an implementation in Smalltalk. And that the Smalltalk implementation is aided by an environment that gives you a slightly different source language than pure Smalltalk. And the same is true for Chi4J, and that's going to be Ricard's talk, which is coming up right after mine. I think a lot of the future of DCI is in the hands of people here in the audience, like Trygve said, who can take this forward, who can try this out, who can build the environments. And you know, I have a lot of faith in Ricard and in J-Way and the work that they're pursuing. That's where Steen is from as well. So there's been this nice little cadre working on these things for the past couple of years pretty intently. I'm going to pick up on a lot of themes that Trygve introduced this morning and kind of drill down into them. One of the things that Trygve said very early in his talk is, well, we have this term called object-oriented programming, and I sometimes call it, you know, your old professor's object-oriented programming or your grandfather's object-oriented programming. And the idea here is having smart data. We're going to make the data smart. And so a savings account is not just something to which I can increase the balance and decrease the balance. Okay, it can do funds transfers. It can do automatic interest calculation. It's a smart object. And then pieces of the business logic with the domain logic. And both get in the way of understanding the other. And because we can only integrate little pieces, and they're kind of mixed in with all this domain logic, it's really a mess. So DCI is an approach to not only programming, but I'll also show here in a second design, where we're dealing with sequences of tasks toward a goal. Now, what do you know about sequences of tasks toward a goal? How do you capture those? You're an analyst. You're a designer. No, as an analysis formalism. But yeah, we'll eventually get down to algorithms or procedures. Yeah, it's a use case. Use case is not Swedish for scenario. Okay? A use case is something that is moving toward a goal. Okay? And this is usually a business goal. And we're going to talk about this. And that's where DCI really shines. If you have an environment that's a graphical editor, where all you're doing is saying things like change the color of this circle or move this circle, I mean, you still can use the DCI style of programming, but the benefits are less clear because there really isn't a sequence of operations. It's more atomic. So kind of rising above DCI is this taxonomy of design approaches to using, what we call object-oriented programming, whatever that means. And so I've divided these up into two families. One is called atomic event cases, and this is your grandfather's object-oriented programming. And it's probably just fine for things where all you're doing is changing the color of an object on the screen or doing something simple. Now, Trygve would argue there are benefits even there for using DCI, and you actually ran some examples about this. We corresponded a little bit. And that may be true, but what we've been doing is very well suited to this. If you start getting complex use cases, then your grandfather's object-oriented programming breaks down. So I want to start by saying there are these two styles. Okay? In the old style, we mix business logic with the domain logic. In DCI, we separate it. So you notice I'm starting with this at the level of analysis and design conceptualization rather than starting at the code. We'll get into the code here very soon, but I want to set context because what we're after here, and someone at the break asked me about, so who is this guy I mentioned this morning, this B.L. Worf, who's a guy who claims that language is not only a way that expresses our thinking, but it in fact shapes our thinking. A very important goal of a programming language is to capture the intent of the programmer. And this is a property of a program called intentionality. I should be able to read the code and understand the programmer's intent. What did the programmer intend this code to do? That's really what DCI is about. So when we talk about agile or agile architecture or lean architecture, it's about individuals and interactions. Well, are programmers individuals? Are they stakeholders? Scrum people. Your product owner represents stakeholders. Are the programming team members stakeholders? Yeah. Are there things you can do for them to increase ROI? Yeah. So, good programming techniques help them too. This is a lot for the programmer as a stakeholder, but we're also going to be paying very close attention, as Trygve said, not so much to the customer as to the end user. The customer is just kind of an unlean participant in the process who passes software along one direction and shuffles money another direction. The person you want to be focusing on is the end user. Letting their mental model drive the structure of the program. By the way, that's what we call object-oriented programming, capturing the end user's mental model in the code, and then giving the programmer the tools to be able to express that in the code. That's where we're headed here. So most programs start with two major threads of analysis. One is analyzing let's start here. This is like Eric Evans' books and things like domain-driven design. So Eric and I and a couple of other folks sat on the stage a year ago and talked about domain-driven design and domain-specific languages. Okay, that's all this stuff. And you find the form of your domain, and that's going to become classes. And so this is where class-oriented programming probably is a good way of looking at things as a start. It develops kind of the right vocabulary and the right outlook. But that's how you save money. How do you generate revenues? I mean, software is not a product. As Trygve said this morning, software only has value when it's running in a machine. It has value as a service, not as a product. The value comes in its running. And those are the use cases. Now, I've broken this down in two. There's the use case, which are a set of interactions or of relatively complicated combinations of tasks towards some goal. And then there's something called the event-based style of programming. These are very simple things like text editors, graphics editors, and probably use cases are overkill. Now, one of the things I'll talk about a little bit later, what is a use case that doesn't have a goal? So let's say you're going onto your net bank to transfer some money. Is logging in to NetBank a use case? No, why not? Doesn't have a business goal. I mean, like Gertrude, my wife, taught me a lot about this. And she says, you know, there's no business goal to logging in. You don't tell your children, wow, I got a lot done today. I logged into NetBank 10 times. You know, it isn't really accomplishing anything. But it kind of quacks like a use case and flies like a use case and walks like a use case. And we can capture it as a use case. But all it is, because it doesn't have a goal, is just a habit. And so now we have this concept of habits that they're kind of use case fragments that may recur again and again in use cases. And it's just a place to hang these common notions of sequence. And it may be non-deterministic how you get to the goal. Use cases are not essentially deterministic. We leave the determinism up to the programmer. Well, that means that we need to make it deterministic. That's called programming. And that's turning use cases and habits into algorithms. A use case is not an algorithm because a use case can be non-deterministic. If I'm doing a money transfer, I choose the source account and the destination account. Which one is first? The use case will probably give me the freedom. It's non-deterministic. Which one is first? Ultimately, I need deterministic code. So there's a translation step here, going from the use case to an algorithm. Okay? And DCI is really about capturing the algorithms in a framework that reflects the use cases. What I want to show is how these concepts translate into DCI. Ultimately, it's coming down to objects, which are going to be instances of these classes with a little bit of intelligence that it gets from these roles, these scripts that they read. You know, oh, Romeo, oh, Juliet. That's the script I read. But what I am as Romeo and Juliet is just a bunch of DNA. Pretty dumb. Good objects are dumb, not smart. Otherwise, they're hard to understand. And that's probably against what your professors told you, right? So, we saw Trygve's picture here. I finally did steal these slides. Of having these objects, and we're running these use cases through them. And that's all well and good. We have different patterns that come through, and maybe the same use case comes through, and this time it uses this account, and next time, same use case, uses this account. First I withdraw something from my checking account, now I withdraw it from my savings account, but they're both withdrawals. And I end up with this soup that I really can't understand. What I want to do is draw out the interactions, and I do this in terms of the roles that the objects play. And the roles have methods or behaviors that I can use to reason about the state of a system. One of the important things about your grandfather's object-oriented programming is you couldn't reason about the state of the system. You could only reason about the state of an object. Well, if you can reason about the state of an object, how can you have any assurance that the behavior, which is the thing you sell, has value? So now we're raising the value proposition, right? We value the behavior, so that's what we're going to focus on. The state of the system and the behavior of the system, not the behavior of an object. You all know I'm a big opponent of test-driven development, and this is why. Because TDD is about the state of an object that has no business value. What has business value is the state of the system and the behaviors, like in Dan North's BDD, where you're dealing with things at this level. And so each one of these interactions operates in an arena called the context. What is a context? Well, a context is essentially a use case. It is a collection of related possible scenarios between an end user and a system under construction. And so for every use case I have in my analysis, I'm going to have a context that represents it. So now I have more of a seamlessness that goes from the analysis world into the architecture and coding world. I have an architectural home for use cases. Now, these are not just procedures, for the reason I mentioned this morning at the break, because these are procedures that get glued into the objects that they're operating on rather than interacting with the objects through some interface. Okay, they get injected into the objects. And that gives the object a conceptual identity. It's more like the end user thinks of it. But you think of things in terms of roles, and what I like to do, who here has done a money transfer between accounts recently? Anyone have multiple bank accounts? You've done a bank transfer? So you've done a bank transfer? So give me kind of a generic little story, user story. What does bank transfer mean?
I don't know. Getting them from one place to another.
Okay, be a little more precise than one place and another place. Let's develop a little vocabulary here. We'll do this iteratively.
Getting them from my possession, from one person, into some other person's possession. Maybe paying something or...
Okay, but talk about it in terms of banking artifacts, in terms of accounts.
Money transfer.
Okay.
I don't know where you're getting at.
Oh, yeah, I know. I'm fishing here. It's a little hard. Usually when I ask someone this, 9 times out of 10, they'll say, well, you know, I take money out of the source account and I put it into the destination account. I choose my source account, I choose my destination account, I choose the amount, and I say transfer. I don't have a source account. Anyone here have a source account in their bank? You want one, yes. Great idea. And so these things that are source accounts and destination accounts aren't objects. They're how objects act. They're the roles that objects play. Are you a son? Are you a brother? Are you a father? No? Are you a programmer? Somewhat? Some would say. Okay, what are you anyhow, right? An object can play multiple roles. No problem. A role can be played by multiple objects. There's this many to many to many mapping that goes on in object-oriented design that I haven't seen a single design method talk about, because they're driven by the programming language models that were developed during the 1980s. I mean, Trygve and I like to talk a lot about the computational models of objects. The computational model of C++ is pretty weak. It's good for what it does. The computational model of Smalltalk is beautiful. It's object-oriented. And they destroyed it with the language. Smalltalk is just C++ with a funny syntax. It's still classes. So all we've been able to do all these years is class-oriented programming. And we need to do object-oriented programming. So we have, this comes back to some new analysis and design concepts. We have use cases. We have these habits, which are the parts that we can tease out of use case and eventually turn into a reusable algorithm. We have this event-based way of looking at things. We talk about the interactions in terms of roles, like source account and destination account. We still have classes, and these are the templates for these dumb domain objects. And we have algorithms, and these are going to be the end product that comes out of design as we take use cases into implementation. I think I'll actually skip this slide. You probably, if you've studied use cases, you know about the includes relation in use case. And the reason it's harmful is because you end up breaking down use cases and decomposing them all the way down, but none of these things have a goal. So, I mean, how do you talk about, well, logging in? Is that a use case? Nah, it really isn't. It doesn't have a business goal. It's not the kind of thing analysts like to talk about. So we need this other concept that's a programmer-owned concept, and that's what these habits are. And these allow programmers to talk about reusable chunks of functionality, but you don't want to confuse the end user with those, because they don't care about code reuse. They don't give a darn. They just want the system to work. And what we like to do as programmers when we write our use cases is foresee the reuse and factor out the common scenarios, and that's what includes is all about. And it's a nerd concept that we've thrown at our customers. Don't do it. Okay? Keep use cases goal-driven and use habits for these things that are lower level. All right, let's start to get into some code. So here is a savings account. Now, this isn't quite right, but we'll come back to it later. Let's pretend that savings accounts are objects. And as an object, we can capture what's of interest about these objects in a class. So here we have a savings account, and it's derived from account. And this account will be made smart later. So we're going to send this account into the matrix, or the right part of the matrix. Geez, I love that image. You know, to get injected with the right program at the right time so it can do what it needs to do, like fly a helicopter or... And then when it's done flying the helicopter, we don't need that program anymore. It can kind of be garbage collected. And, you know, this intelligence will come and go in objects as needed. So, you know, you put on your father hat when you're a father, your brother hat when you're a brother, your programmer hat when you're a programmer. And sometimes we even confuse them. And if there's maybe good ways of confusing them, no problem. So what is a savings account? Well, it has an initialize method that's probably private. And I'm going to initialize it with an account ID and some initial balance. When I bring this account into existence, it's going to go up to its base class object and initialize that. And then what are the methods on it? There's actually very, very few. I want to ask its available balance. I could have made this a Ruby getter, I guess, but I hate those getters. We'll see one later. I can decrease its balance or increase its balance. Now notice this isn't withdraw and deposit. What's the difference? A lot. What is a withdrawal? A withdrawal involves transactions, all kinds of checks, checks on preconditions, checks on validity, checks to fire triggers, to send notifications. I mean, a withdrawal is a fairly complex business transaction. It doesn't belong in a dumb object. All that belongs in a dumb object is this thing is essentially a smart floating point number. Okay? This smartness is going to come from somewhere else. Why do we have the smartness somewhere else? Because it's the smartness that we sell. And we want to be able to add the smartness incrementally. So if we have a new customer who wants a new kind of smartness, like the ability, I want this account to pay all my bills. Okay, we'll define some roles from the use case, pay all bills, and we'll inject the right parts of that use case into this class at runtime to make it do what it needs to do. And then we don't have to worry about this dumb domain class. That can remain relatively stable. Good design is about separating what is stable from what changes. And most domain concepts remain stable over time. Your grandfather's architecture kept upsetting them by putting smart things in the interface every time you got a new use case. So nothing was stable anymore. Oh, we'll handle that with inheritance. But now you violate abstraction. Because now you have these nice base classes that you want to treat in a nice general way, and you have to dive down into the inheritance hierarchy to get to the interfaces you've added. So that doesn't work either. There's a lot of things we tried over the years that don't work, that DCI just blows away. So, kind of the trick. If you're a sumo wrestler, every sumo wrestler has one trick that they can use. And if they get to use that trick when they're wrestling, then they will probably win. So this is kind of the sumo wrestler's trick in DCI. And it's this concept of injecting functionality. Now, there's a lot of techniques we can use for this. The most common techniques look like class composition. So you all have this notion of what a composition is, but you think about composition in terms of object composition, that I have an instance of one class inside of another. So what is the relationship between class person and class heart? That isn't what I asked. I said, what is the relationship between class person and class heart? If I have an object who is a person and a heart which is an object in that person, I can talk about that relationship. That's HAZA. But there is no class relationship. This is why class-oriented programming doesn't work. And if you look at early the Booch notation, this notion of HAZA is hopelessly confused because it confuses the class-level relationship with the object-level relationship, and they are different. And here what we're going to do is compose two classes together, not objects. So we're going to have a class called a source account, this thing that I withdraw money from, and a class called the savings account, and we want to glue them together so that now the object gets the smartness of being a source account. How do we do that? Here's how we will do this in Ruby. So in the initialize function for the context is a very special object. There's one of these per use case. We'll see a little more about the context object later. This is the context object for the use case transfer money, transfer funds. And what it's going to do is it knows the roles for transferring funds. There's an amount, there's a source account, there's a destination account. Those are the roles. And what it needs to do is wire up those roles to the objects that will play those roles. We call this casting. Right? Okay, in this play, you're going to play this role, you're going to play that role, and you'll play this role. Or you'll play this role, and you'll play this role. Ever been to a play where one person plays two roles? No problem. A many-to-many-to-many mapping, where we have free association and can do what we need to do. Okay? So what this context object does is I set it up with the amount, the source ID, and the sink ID. You know, where's the money coming from, where's it going to, and how much. Now that's the context, and the context, based on these arguments, is going to go find the right actors. It's going to go into the database and bring out the right objects and say, well, this one is going to play the role of being the amount. This object that I find from this ID will play the role of being the source account, and the one that I find from this ID will play the role of being the destination account. And the context job is to set up that mapping and to keep track of it and to answer questions to the methods. Hey, context, I have this role called the destination account. What object is it? And the context says, well, here it is. Thank you. All I know is I want to talk to a role called the destination account. In the end, it has to come down to an object. And the context is the one that does that lookup for me. How does the context set things up? Well, here for the source account, it's extending it to include the methods of transfer money source. So every object that gets implicated in a transfer money use case will be made smart right here so that it can be a transfer money source. It gets the methods of that class. This is class composition. Now, actually in Ruby, it isn't quite class composition. This actually happens on an instance-by-instance basis. In Scala, it's anonymous class composition. In C++, it really is class composition. And the common word for this is something called a trait. So a trait is kind of like, where's my aspect guy? Trait's an aspect. There you go. Why not? That's one little piece of the puzzle. Okay? In C++, how do I do this? I do the gluing using the indirect template idiom. And so what this does is this glues together a class savings account with a transfer money source class, which takes a savings account as a parameter. Okay? And so I do derivation in one direction and template argument in the other. So these two classes compose with each other. And if I instantiate an object of this class, it will have the behaviors both of things like decrease balance and the behaviors that come from transfer money source in one object, because I've glued the two classes together. This is a very static way of doing it, but that's what you have to live with in C++. So Ruby is very dynamic. Python is even more dynamic. You kind of rewire the method table. Smalltalk is very dynamic. Scala is kind of in between. It's static, but has a lot of variation. And Smalltalk, yeah, again, very dynamic. Now, this is hard to read, but goes into this issue that we need to translate use cases to algorithms. So here's a use case for transferring funds. It may ask, the system should verify the funds available, then the system updates the accounts, and the system updates statement information. Rebecca, I want to talk with you tonight about, how in the heck do you really formulate this as a use case? Or is this a use case at all in the sense of the word? But Gertrude remembers hearing something from you way back when about how you treated cases like this where you have a whole bunch of system responses. So it's kind of a use case technicality question. But that isn't the algorithm. The algorithm is more detailed. It includes transactions. So the source account begins a transaction, verifies funds available, reduces its own balance, requests that the destination account role, the object playing that role, increase its balance. The source account will update its log. The destination account will be asked to update its log. And then we end the transaction and we inform the account holder with a splash screen that things are okay. So that's the algorithm. It is some roles participating in interactions, and now we need to distribute the responsibilities across those roles. And as we heard this morning, this is responsibility-driven design from this point out, taking these responsibilities and distributing them across the roles. Here's a role. This is what's called a methodful role. These don't exist in Java. You don't have methods on roles in Java. In DCI, the roles have methods, so they're not just interfaces. So here's transfer 2. And it's just, I can read this. I can do code inspections on this. I can hand this to my office mate with a big red pen and say, does this make sense? If I do this in your grandfather's object-oriented programming way, the methods are you put them in a box with some dynamite, and you blow it up, and they end up scattered all over the place. And you can't understand the algorithm anymore. Here, the algorithm is a full first-class citizen, all the way from analysis into the code. And here I can read it. And it talks to the rest of the code in terms of the roles that are bound to the methods. No problem in C++. We can talk about roles like self. Trygve this morning said self is the object playing the current role. We have a method or a role called a recipient. So on self, decrease my balance by the amount. On the recipient, increase the balance by the amount. Then update my log in the recipient's log, display a splash screen on the GUI, and the transaction. I can read this, even in C++. What if I want to do pay bills? Okay? So, transfer funds is a use case. How do I represent use cases? Well, as a context. And so what I want to do is transfer funds from my source account to a whole bunch of destination accounts that represent creditors. And so I can kind of write code like this. So assume we can find the creditors, and then for each creditor, iterate over this with a little iterator, and just pay every creditor what they're due. In order to make this work, we need the full-fledged context in place. We saw this little snippet of code before that actually does the lookups in the bindings. There's some other code in here. What does it mean to execute this use case? Well, what we're going to do is we have a singleton method here, define self.execute on these parameters as instantiating an object of transfer money context and then executing its execute method. That's here. And all it does is it says source account transfer to. And the rest just happens. Because all the wiring has been done here. We just go to the first role in the use case initiate it with an event, and the rest just happens. This execute in context is a way of stacking the context. Context stack. We'll see why that's important in a second. So I can call a context. This is a way of reusing use cases, or really reusing habits, where I can build a context that represents a habit and call it from within another use case. So here is, within some context, the definition of the pay bills use case. Okay? So it's going to go to the context and get the creditors, make a copy of that, because we're going to iterate over it. We don't want to deal with the original. And then for each creditor, instantiate a transfer money context and execute it with these arguments. Pay the bills. This pays all the bills to all my creditors, reusing this use case that has been put into that context. It will figure out what the role object bindings are. I don't have to worry about that here. This reads like business logic. I can reason about the code. I have high intentionality now, which I don't get if I use standard object-oriented design. So this is a very good fit for these things called habits. They're kind of like slices of use cases that compose with each other. And this gets to this issue of chunking that we talked about this morning. I mean, it might be nice to have the full use case laid out before you, but you couldn't understand that anyhow. We understand things by compressing and, well, there's two basic cognitive tools. One is divide and conquer. That's called partitioning, and the other is compression. And we need both. And so this notion of context is a way of doing the divide and conquer, of splitting things up into units of use cases that we can understand. Roles are a further chunking of functionality in terms of things that we understand. And this is what gives me the cognitive tools to be able to reason about the program. Okay? Now, one more point. I have about 5 minutes left, do I? 10 minutes. 13. Ooh, we're doing really good. So I said an account is an object, right? I lied. Anyone here do banking software? What are the objects in a bank? Are they accounts? What are the objects? You're an auditor, right? You have a visa in a bank. What are the objects you talk about? What makes up a banking system? Transaction logs, audit trails. What is the balance on your account? It's an iteration over an audit trail, adding up all the deposits and subtracting all of the withdrawals. Your balance isn't sitting on a disk somewhere spinning. It's computed. It's a use case. An account isn't an object. The account ID might be an object, but the account is an active thing, in your terms, a business process. Okay? So it's not really an object. Well, what is it in DCI? Because if it's an object, then it's a domain object, and it has to be smart. Right? We don't like smart domain objects. They don't evolve well. Stuart Bront, who's an architect, writes some architecture books. He says that buildings have what are called shear layers, and that there's some parts of a building that change very slow, like the stone foundation. You only change that once every 500 years or so, maybe 100 years. And then the walls. The load-bearing walls change very seldom. The internal walls may change every 30 or 40 years. You build a new room. The paint on the walls every 10 years and the carpeting on the floor every couple of years. There are these shear layers. The same is true in software architecture, is that there are shear layers. And the stuff that's the foundation, we don't want to be going in there every time we get a new money transfer or a new financial instrument that we want to sell. We want to separate these. And that's what DCI is doing, is it's separating the stuff that changes from the stuff that is stable. So accounts are pretty stable, but they're behaviors, okay? Is an account part of the end user mental model? Of course, we talk about accounts. So it must be a thing. If we're doing object-oriented programming, which is capturing the end-user model in the code, then it should kind of fly like an object and quack like an object and walk like an object. Well, what is it? It's a context. An account is a context. What is a context? A context is a use case. Well, can we make a context to be a collection of related scenarios that involve a certain set of roles? What is a collection of related potential scenarios between an end user and the system under construction? That's a use case. And we reflect it in DCI as a context object. And so we have these roles up on top, and I show them as kind of, they aren't really objects, they're roles. They have the algorithms in them, but they really don't have state. Most roles in DCI are stateless. They are pure algorithm. The state has to be remembered in the domain objects. And each role works with one or more contexts or gets injected into some domain objects so that contexts can organize their bindings and kick off new executions as events come in. But it turns out that contexts themselves, which are the blue things here, can behave like domain objects, like savings account does. It's not an object. It is a collection of interactions between roles around a set of scenarios that we call use cases. And so this kind of solves a very, very, very long-standing problem in object orientation, because everyone wants to make an account an object, and it really isn't. And there's all kinds of problems with the lifetime of these ideas if you treat them as objects. It's the algorithms of an account that are long-lived, and the identity of the account. The account identity may be a long-lived object, but not the account. Things like the account balance are very ephemeral. So they're computations. We now have an architectural home for these computations that you don't find in most object-oriented methods. Now again, smart designers have done this for many years. They make stateless objects, right? And they know that those things are there. But there's no real design vocabulary, formalism, or computational model to support this. It's all ad hoc. What we're trying to do here is kind of build a small theory of design that maps onto the way we think about programs and think about business domains so that we get high intentionality. So in the end, this is cleaner code than you get by distributing these responsibilities all over the place. It's readable. And like Trygve said, I'm not going to rely on testing to test quality into the product. I'm going to rely on thinking and understanding. And that's a very lean approach. It's agile because I can introduce these roles at a very fast rate. It's easy to add new roles and to get them injected into objects. Agile is about doing things fast, doing. There is no thinking in Agile. Show me thinking in the Agile Manifesto in one place. Lean is about thinking and doing. This is moving into lean territory where we need to do analysis and understand our end users' mental models and understand how to translate it into something the programmers can deal with cleanly. So we have this mixture of lean and agile that's going on in the architecture. Okay? The architectural expressiveness, I mean, you know, from my perspective, it's moderately better. It's not a great revolution in architectural expressiveness unless things like these contexts are very, very important to you. Where the real power seems to be is in maintainability, because it's separating the shear layers and it's making the use cases much more readable in the code. You get much higher intentionality. And even I, Trygve, am becoming more and more convinced of the need for a supporting environment. We've had this fight for the past 2 years about, and I say, no, it's not about tools, it's people and interaction. He says, we need a tool, we need a tool. When anyone says we need a tool, I get really nervous. But he's starting to convince me, and you know, I think probably my relationship with you was, with Ricard here, was kind of the cementing thing. I mean, if you need to debase yourself to programming in a language like Java, then you need an environment to give it the expressiveness of DCI to be able to do the kind of things you need to do. That's what I had to say. We have 5 minutes for questions. Any questions? No questions? Come on. It's an after lunch crowd. Going once? Going twice? Yeah, I know I could count on you. Good. Mm-hmm. 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 Yeah, there's a lot of engineering rules about this. By the way, I'm writing a book called
Sorry.
Oh, repeat the question? Yeah, so I said that domain models should be dumb. Do I have any rules for saying what things should go there and what things don't? It has to do with this concept of shear layers and understanding how stable are things. And so you go to something like Eric Evans' book on domain-driven design, right? And you look for the things that are stable. Those are the things that I want in my domain model. If things are going to be part of things I sell to the business that are more dynamic, I want those in the roles. And so it's really another way of looking at it. It's a dichotomy between what the system is and what the system does. So the domain model, the dumb classes down there are what the system is. So a system is transaction logs, audit trails. Okay? What it does is transfer money and pay bills. And this what the system is tends to be stable. I mean, it's what Code and Jordan would call the data model, right? And in fact, that's a D in DCI. Data, context, and interactions. I have a data model. Data model. Model view controller. This is the programmer's side of MVC. MVC is the end user side to get their mental model lined up. This is getting the programmer's mental model lined up. Same model, same M. I need to go back and read Peter's stuff, because most of my interaction with Peter has been on panels at Oopla and stuff, where basically he plays the clown to entertain. But if you read his stuff, there's actually some unbelievably profound ideas. And frankly, I mean, there are things that I have a hard time understanding, like his colored code model. And I really suspect that there's something extremely valuable and deep there, but I can't quite get my mind around it. And it's related to this. Yeah. Yep. So, I mean, he's got some of this, or at least he's looking at some parts of the elephant. But like I said this morning, this is what everyone says. This reminds me of aspects. This reminds me of Peter Code. This reminds me of dependency injection. This reminds me of multi-methods. This reminds me of multiple inheritance. Yeah, you're all right. In the same sense that each of the 5 blind men was right about the elephant. So, I mean, DCI is this composition of ideas that relate to all of these things. And it's very easy for us to relate to the things we know, right? So we take what we don't know and try to relate it to what we know. So therefore it's aspects, or therefore it's Peter Code's colored stuff. The colored stuff, though, I think is a little more interesting. There's something actually going on there. You know, he's no longer in software. He sold his software company, and he's now chief pilot of his own airline. Peter's a weird guy. He's yeah. Oh. No, I haven't. I mean, I could give a 2-day tutorial here, but I'm trying to whet people's appetite. So let me first of all repeat the question and answer this one, and then if you have another question, we can go there. So the question has to do with behavioral composition, and yeah, there's a lot of formal research on the semantics of behavioral composition, including Richard Helm's early paper at OOPS and Rebecca is asking here, how do we deal with things like exceptions? Well, right, and so a use case is 90% the exceptions. And so what I've talked about here are the main success scenarios, but the context still encapsulates all those extensions, all those exceptions, all those variations. It's all there. It's just more code. It's more algorithm. And that's why, I mean, and Gertrude and I had this argument because from these examples, she would say, well, these aren't use cases. They're only scenarios. And I'm saying, no, 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 no. I mean, you can put all of the use case knowledge, including all of the extensions and variations in this context. It's not a problem. You just deal with it. It's just, that's where the code goes, and it's there. Just like we ordinarily code up scenarios. Yeah, I mean, there's a lot of things I haven't shown you because, you know, they limit me to 50 minutes here, and it looks like I'm about to get pulled off the stage. But, yep. All right, I guess I'm done.
Yeah.
Thank you much.
Thank you, James.